Hey everyone, welcome to lesson 122, day 2. We're going to be talking about asymptotes with domain and range. Our content goals today, we want to be able to identify domain and range of a rational function. Yesterday we had talked about rational functions, but we didn't really talk about the domain and range. We found all of the other key points. So today we're going to add in how to identify and write the domain and range of a rational function. We also want to understand why rational functions have an asymptote. We'll talk about that in more detail today, and we'll also look a little bit at the dilemma of dividing by 0. All right, so like I said yesterday, we introduced a new function called the rational function. It typically operates in this form, and it's any function that has the x in the bottom of a fraction, right? If it has the variable in the bottom, like the one we're going to be dealing with today, so it might not look exactly like 1 over x, it might look more like this, where the x is in the bottom with some other stuff, and that's okay too. All right, this is still a rational function. Now today, instead of building the table and the graph, I have already built the graph for you. And remember, the new graphical feature that we talked about were these asymptotes, which are these dashed blue lines that we see here. This is a part of the graph that the function cannot pass through or pass over. All right, so these are the asymptotes. The red part is the actual function. It's important to not get those confused. All right. Now most of this stuff we can zip through. We should know how to find x-intercepts and y-intercepts, mins and maxes pretty easily. All right. Do note that this function will continue on in all directions forever and ever. Okay, so the arrows are not drawn in there, so you might want to draw those in just to remind yourself that we do go on forever and ever there. All right. Now x-intercepts, right? So we're looking for the part of the graph that crosses over the x-axis, and that is located right here. All right, so it crosses the x-axis at 0, so I'm going to make sure that I say my x-intercept is at 0, 0. Obviously 0, 0 is also a y-intercept, right, because our y-axis runs vertically right here, and it crosses over that y-axis at the same exact point, so we're going to get 0, 0. Okay, minimums, we're looking for the lowest point on the graph, so we have to consider both parts of this rational function. So we have a red curve down here, and we have the other red curve going on over here, and we want to go low, right, because we're looking for a minimum. And so I'm tracking my graph down here, but it's never going to stop going down, which means we have no minimum. There's no lowest point. Okay. Same thing with the maximum. If I want to go high, right, I would jump on this curve over here and track it because it's going up, but it's never going to stop going up. So we would say that it has no maximum. Okay. Horizontal asymptote, right? Horizontal means left to right. All right, so that's going to be this one right here. And I know this was confusing for some of you guys yesterday, but a horizontal asymptote is going to have an equation y equals, because that horizontal line crosses over the y-axis somewhere, okay? Particularly right here, all right? So we're going to say this one has a y, or a horizontal asymptote at y equals 1. Vertical asymptote means it runs up and down. Okay, so this is my vertical asymptote, and it's going to get an x equals equation. And that's because a vertical asymptote is going to hit the x-axis somewhere, right? So it's going to be right here. It's a vertical line. So it's going to hit the x-axis at x equals 1. All right? So now we're going to talk about the domain. This is the new thing that we're talking about today. How do I write the domain of this crazy looking function? So a little bit earlier, you had heard me say there's two different parts to this graph, right? There's a curve over here, and there's a curve over here. All right. So essentially, there's two parts to this function, which means I'm going to end up writing two domains. All right. So I'm going to start with this curve over here, right? Because we want to start as far left as we can go, and this curve has the part of the graph that's going off towards the left, right? This is going to have the leftmost part of the graph. So if I track this part of the curve off to the left, and I ask myself, well, how far left does it go? Well, it never stops, right? So it's going to go all the way to negative infinity. So I'm going to start by writing my domain with a negative infinity. And then I say, well, okay, well, if I stay on this particular curve and I head off to the right, how far to the right does this part of the rational function go? And it goes as far right as right here, right? It'll get infinitely close, but never touch this vertical asymptote, which occurs at 1. So this is going to go from negative infinity to 1, but we can't actually get to the 1, so it gets a curved parenthesis. Same thing with the negative infinity. It's going to get a curved parenthesis as well. So now I jump over to the other curve, right? And I say, okay, we go left to right. So I say, well, how far to the left will this thing go? And there it is. I'm going off to the left. It is going to go up and to the left forever, but it will never cross over this vertical asymptote, which again happens at 1. So I'm going to say 1, comma, and then I'm going to go back to the right. Right? How far to the right does this thing go? Well, that arrow tells me it never stops going off to the right. So we're going to go from 1 to infinity. And again, it's going to get curved parentheses because we can't get to the 1 because of the asymptote, and we can't get to infinity because, well, it's infinity, right? Now, last thing you need to know, we've got both of the intervals written here, but the last thing you need to know is when we write two separate intervals for a domain, mathematicians join them together with a special symbol that looks like a big U. And this is actually called a union symbol, and it unions these two things together. Right? It says this interval or this interval. Okay? So pretty much everything except for 1. All right, let's talk about the range. Okay? Remember, range is low to high. And again, we have two separate curves that we have to consider. So this curve is going to be the part that has my low because it's got this thing down here going all the way down to negative infinity. So that's where I'm going to start my range. That is the lowest point, negative infinity. And I'm going to finish this curve. And I'm going to say, how high does this thing go? So I'm going up, 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 up. Now it starts going off to the left, but it's still going up. And it'll keep going up forever and ever, except that it won't cross my vertical asymptote. And that vertical asymptote is at 1. So we're going to go from negative infinity all the way up to 1. I can't get to either one. And then I'm going to hop over to the other curve. Right? So now I'm over here. How low does this curve go? Well, it goes low, 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 but it will never cross over this horizontal asymptote, so it'll go as low as 1. And then I see how high it goes, right? And I'm going up, but it'll never stop going up, so it'll go all the way to positive infinity. And then I union it. So there's my domain and range. It's essentially like writing 1 for each curve. We know they're going to be unioned together, and the numbers that go in these parentheses are actually related to wherever those asymptotes are located. Okay? All right. So what creates an asymptote? Well, the idea that we might actually divide by 0 at some point. So consider this function, 1 over x. Okay? If I try and do this calculation, if I put a 0 in for x and evaluate this function, I'm going to get 1 divided by 0. And I'm going to go to my calculator here, and I'm going to try and type in 1 divided by 0. Right? So there it is, 1 divided by 0, I get an error. Right? Can't happen. The calculator doesn't know how to do it. All right, so when we go to our graph, right, if I were to take this function and graph it, this is what I would see. All right, when I try and get to x equals 0, there's nothing there. Right? The function bends because once we get to 0, the calculator doesn't know what to do. Okay? We can also see that in the table. When we see the 0 here for x, we get the error for y because it doesn't know how to calculate or evaluate the function at that particular point. All right? So that's why we get an asymptote, is because of this 1 divided by 0 situation. Well, why can't we divide by 0? Why doesn't the calculator know how to do this? All right, and I think the easiest way to explain this is to think about a cake and visualize dividing a cake. All right, so let's say I have one cake and I'm going to divide it, right, or cut it into pieces. Right, that's what division means. It means we're going to take something that's a whole and we're going to cut it into pieces. So let's say I take 1 and I divide it by 2. That would mean I'm going to come over here to my cake, I'm going to take my knife, and I'm going to cut it into 2 equal pieces. Right? So that would be 1 divided by 2. Well, what if I did 1 divided by 4? Right? Well, that would mean that I'm going to come over here to my cake, and I'm going to cut it into 4 equal pieces. Right? 1, 2, 3, 4. But now let's say instead of a 4, I put a 0 there. How can I take one whole cake and cut it into 0 pieces? You can't, right? It doesn't make any sense. There's no way to take a knife and take an entire cake and cut it into nothing. You can cut that cake all day long. There will always be cake there. All right, you'll never end up with 0 cake no matter how you divide it. That's why it doesn't make sense to divide something by 0. That's why the calculator gets confused, and that's why we end up with asymptotes on our graph whenever we have the possibility of dividing by 0. All right, guys, that's it for today's lesson. I hope you have a great day. Give those practice problems a try.